Hello students, myself Dr. J.P. Sridhar, Associate Professor, Department of Electrical Engineering, SJBIT. Today I am going to discuss two important topics, that is differences between Butterworth and Chebyshev filter and also differences between impulse invariant and bilinear transformation. These are the two important differences. Usually they will ask an exam for 5 to 6 marks. Let us start with one by one. So coming to the first one, differences between Butterworth and Chebyshev filter. We can go to the first difference. Let us see the magnitude squared response of the Butterworth as well as Chebyshev filter. We can see here as the frequency increases, we can see the gain. Okay, it is a constant at initial stage, and again it starts increasing, and again after a certain time period, okay, again it starts decreasing. Okay, so you can observe. So at the starting it is constant, as frequency increases it's slowly decreasing, and again it becomes constant, and again it starts decreasing. You can see the Chebyshev filter, we can see the ripples present in the pass band. So if the ripples are present in the pass band, it is called as type 1 Chebyshev filter. Suppose if the ripples are present in the stop band, then it is known as type 2 Chebyshev filter. Okay, so this is the first difference. Okay, so coming to the second one, let us observe the magnitude response h of j omega decreases monotonically as the frequency omega increases from 0 to omega. As I said already, initially it is constant. Okay, as frequency increases, the gain starts decreasing, again it comes to minimum, again it becomes a constant. So this is the magnitude versus frequency in case of Butterworth filter. Whereas Chebyshev filter, the magnitude response exhibits ripples in the pass band and also ripples in the stop band. It depends on the type of the filter. If the ripples are present in the pass band, it is known as type 1. If the ripples are present in the stop band, it is known as type 2 filter. We can go to the next difference. So next difference is, for the given specifications, IIR order filter, okay, you will get it in the Butterworth filter. To design any filter, we know what are the minimum specifications required. We required Kp, we required Ks, we required omega p, we required omega s. To design any analog filter, we should know the pass band gain, stop band gain, pass band frequency, stop band frequency. Either it is Butterworth filter or Chebyshev filter, we require these 4 specifications for design of any filter. So in case of Butterworth filter, for these specifications usually IIR order will be obtained. Similarly, for the same specification in case of Chebyshev filter, we are getting the lower order filter. This is also one of the major difference. Next, wide transition between pass band and stop band. There should be a gap is more between the pass band and stop band, whereas in Chebyshev filter there should be a sharper transition between pass band and stop band. This is also one of the difference. Next, go to the next one. In case of Butterworth filter, the normalized poles which are lies on the circle. Normalized poles are lies on the circle. Whereas in case of Chebyshev filter, the normalized poles are lies on an ellipse. Okay, this is also one of the major difference. Next difference is, we required only few parameters to be calculated to design the Butterworth filter, whereas large number of parameters are required to calculate the design of the filter. So it means that in Butterworth filter, we know already Kp, Ks, omega p, omega c is required. Directly we can calculate the order of the filter n. Okay, whereas in Chebyshev filter, we have to find the critical frequency omega r, we can find out epsilon, we can find out a, we can find out g, then we can calculate n. Okay, so that's why, so to calculate the design, to find the design, so we required more number of parameters in Chebyshev filter as compared to Butterworth filter. This is also one of the major difference between Butterworth and Chebyshev filter. Next difference is, in case of Butterworth filter, the transition band is more. For the given specifications in Butterworth filter, the transition band is more, whereas for the given specifications, the transition band is less in case of Chebyshev filter. So next difference, for the given specifications or for the same specifications, we can find the number of poles are more in case of Butterworth filter, whereas number of poles are less in case of Chebyshev filter. Why the poles are more in Butterworth filter? We know we are finding the Butterworth polynomials Sk, okay, for finding both right of as well as left of poles, and out of that we are considering only the poles which are located at left of poles. Therefore, the more number of poles are present in the design, where you choose only the left of poles and right of poles are neglected. Whereas in case of Chebyshev filter, it is not like that. It depends, the poles depends on the order of the filter. Here we are not need to calculate if the pole belongs to right of or left of the S plane. So the poles are only related to the length of the filter. These are the few differences, okay, we discussed as compared to Butterworth and Chebyshev filter. Okay, so you can expect this important topic. You can write any 4 to 5 differences. Easily you can score 5 to 6 marks in exam. Coming to the another important difference, that is impulse invariant transformation and bilinear transformation. These are the two powerful techniques or methods used to convert the given analog filter into a digital filter. Okay, so these are the two techniques we are used generally to convert an analog filter H of S to digital filter H of Z. So what are the main differences between these two techniques as we can find here? So let us see here. In impulse invariant method, the mapping is many to one. The mapping is many to one. Whereas in bilinear transformation method, the mapping is 1 to 1. The bilinear transformation mapping is 1 to 1. And how we are converting the analog pole to digital pole, how we are transferring, the transfer function is related to Z is equal to e to the power of st. This is the transfer function we are using, okay, in case of impulse invariance transformation, whereas in case of bilinear transformation, the S is given by 2 by t into 1 minus Z inverse by 1 plus Z inverse, okay, and the frequency relation is given by, the frequency and time period is given by how the analog and digital frequencies are related. In impulse invariant transformation is given by omega is equal to, omega is analog frequency, this W is digital frequency. The relationship between analog and digital frequency is given by omega is equal to digital frequency W by time period t. Whereas in bilinear transformation, the frequency relation between the analog and digital is given by omega is equal to 2 by t into tan of omega by 2. This is also another major difference. Next, no frequency warping exists. To convert the digital analog filter to digital filter, we go with the frequency warping in case of bilinear transformation, but there is no frequency warping exists in case of impulse invariant transformation. Frequency aliasing exists because as the mapping is here 1 to many to 1 mapping. So because of that, there will be chances of overlapping the poles or signals. So therefore, the chances of aliasing effect is more in case of impulse invariant method. To overcome that aliasing method, the better version, the better method is bilinear transformation. There we can avoid the effect of aliasing. Aliasing is nothing but the overlapping of the signals on 1 to 1. And impulse invariant method is most suitable for designing of the low pass filter and band pass filter, whereas bilinear transformation is not only restricted to these two, it can be suitable for any type of filter. And it is a linear mapping. In case of impulse invariant method, the poles are mapping from S domain to Z domain is a linear mapping. It is a non-linear mapping. Pre-warping is not required. Here pre-warping is required. So there are almost 1, 2, 3, 4. There are 8 differences are there. At least you can write 5 differences in exam, easily you can score 5 marks. Okay, so you don't need to write 8. You can, which are the simple points, easily you can remember, you can write in the exam and you can score marks. Okay, as you know, as we are solving the problems in the theory classes, okay, we remember that and you can easily write the differences in the exam. With this, I will conclude my